appreciated most is I think what our country needs is more willingness to discuss things. And I think our discussions need to be intelligent, based upon facts, and able to respect other people's opinions. That's what I liked most about him. And so, honestly, I've struggled with this a little bit. That's even if you don't agree with people, respect them and learn to say, okay, we disagree on that part. And then move on. With the social media and everything, you guys get fed what they think you want to see. So everything gets really, really polarized. And sometimes that's stuff like that's the result. And I hate it. Hate it. Okay. Okay. So let's go like this. From last night. Any questions? Yeah.
So the assignment? Like this? Okay.
Yeah. Yep.
So on page 44, 47.
47. Page 44, 47. Okay. So graphing these things, let's take a look at it real super quick. Okay. The y equals negative 2x plus 3? Okay. Well, that one, this is something that, I know, I got to get, this needs to be a little bit darker too. Okay. So where do we start, folks? Plus 3. That's my y-intercept. Remember, this is if my y's by itself, then we know this is in slope-intercept form. So I start at 3, and then from there I go down 2 and over 1. So if I was going to describe that, it's going to be probably steeper than it is flat because I have a slope of 2. Do you see your mistake? Great. Okay. What else? 44. Okay, that's an even, so I need to show that answer as well, and I'll explain it as I go. Okay, so 44. 44, here's one, as I came around yesterday, it seemed like we had people trying to do the equation right away, where here I think I'm going to try and do my work down here so you can see them both since I'm recording. Otherwise, I do it on the board. First thing I think you should do is I think you should take care of your x is less than, x is greater than. That's the first thing I think you should do. And I think that's probably the most basic thing that we can do, that everybody should be able to do. If x is less than 1, something's going to happen. I haven't put down what that is yet. If x is greater than 2, something's going to happen. But I haven't figured out what that something is yet. Okay? So I'll move that up so you can see it a little bit better. Okay? So now I just got to go back and figure out what those equations are. What I saw people doing yesterday as I walked around was they were starting to include the slope, and then they had it, but it ends at 1. So just do this part first. If x is less than or equal to 1, what happens? Okay, well tell me about this. What's my slope of this part right here when x is less than 1? It's 2. What's my y-intercept of that part I'm trying to write an equation for? Yeah, you guys should all be going, it's 0! So if you want to put the plus 0, you can. You don't have to. You can put the plus 0 if that helps your brain go, there's my slope, there's my y-intercept. And then greater than 2, it goes down here to where it's flat, so my slope is 0. And if it were allowed, it would come back and hit my y-intercept at negative 3. So then there's going to be my equation. Okay, so I think it is to me, it satisfies my brain a lot more if I do this part first. And then I go, okay, in this section of the graph, what's the equation? What's my slope? What's my y-intercept? In this section of the graph, what's my equation? What's my slope? What's my y-intercept? Okay. Couple good questions. Anything else? I put a challenging one on there. There's no doubt about it. Remember, anything that we have on assignments is going to be fair game for quizzes on the most part. There's one you guys should be asking. 37. You guys didn't get 37, did you? Well, you need to ask 37. Does anybody have any other questions? Yes. 37A. Thank you, Preston. I appreciate it. If you have the same question as Preston, say thank you, Preston. There was more than that. Okay? So I just want to explain kind of how this works. I'm going to get rid of my book here. Okay? First of all, weddings can be very expensive. There's no doubt about it. They're crazy expensive. Anyway, so in this particular case, the cost of G guest is going to be a couple things. Okay? It's going to be 500 plus something if my guess is less than or equal to 40. Okay? But I'm going over this because I want you to understand really how this works. Well, on this one, I think the first one's pretty straightforward. $17.50 for every guest. Every guest. So, for example, if I had 10 people coming, if I invited all my friends, I'd probably have 10. Okay? And half of them wouldn't show up. But that's my own problem. Okay, focus, Rexroad. Focus. Okay. So if I had 10 people show up, it'd be $17.50 times 10 plus my $500 reservation fee. Okay? That part I think is pretty straightforward. Okay? But on this next part, when G is greater than 40, I'm going to tell you that this is wrong. Can anybody tell me why that's wrong? Because it says, well, what does it say? It says $17.50 for the first 40 guests and $14.75 for each additional guest. Well, my first 40 guests, how much are they getting charged per guest? 14. Well, actually, if on this one they're getting charged $14.75. Is that right? No. So we've got to write something confusing, something that's complicated that breaks it apart. My first 40 guests, what are they going to pay? And my rest of the guests, what are they going to pay? So here's what we need to do. We're going to go 500 plus the first 40, and then the next 40. The first 40 are going to be charged $17.50, and the next 40 are going to be charged $14.75. Well, if I have something more than 40, what number should I put here? $17.50 times 40. Because I'm going to have that full 40 guests at $17.50. Boom. So now let me ask you some questions. I'm going to multiply this by something. I'm going to ask you, what should I multiply that by? Or the question is, how many guests are getting charged $14.75? Well, what if I had 50 people show up? How many people would be paying this rate? 10. So 50 means only 10 would pay this. What if I had 70 show up? Well, I'm trying to build that. Okay, if 70, it'd be 30 people paying this. 100 people, it'd be 60 paying this. So where's that coming from? Well, we take the number of guests minus 40, because the 40 have paid this rate. That's what it should be. The book doesn't have that, because what they did was they went ahead and added those two things together. 500 for the reservation, 700 for the first 40 people, and then the rest of the 40 people, which this excludes the first 40 people by doing this, get charged $14.75. That's a complicated situation. Yes, sir.
Are we going to have a question like that or test anything?
I don't know that we will. I don't know that we will. Because that's but it's one of those things that we still need to ask you if we have questions. Yes, Mayday. Hmm? Yes, you can. You can go G is greater than or equal to 41. Okay? Because we're not worried about half people. I don't know if we have any little people coming to. Maybe that's kids. I don't know. No. But yes, that would actually be very good. Nice job. Okay. Here we go. New stuff. Did I make it? Yes! New stuff. The last class did phenomenal with this. Okay. Parent functions. My guess is it's the first time you've probably heard of the term parent functions. If you haven't grabbed one of each of those, do so now. So we've got that information for both things. First of all, tomorrow I'm excited. We're going to leave the textbook. We're going to do something totally different. Tomorrow's one of my favorite things to teach, and it has nothing to do with algebra, really. But I think it's something important that we all need to be able to recognize. So tomorrow's going to be, I think tomorrow's going to be kind of fun. We're just taking a day, doing something different. And the reason why I feel comfortable doing that is because now I finally see that we've got everybody focusing, paying attention, working hard. Your homework's getting better. So we're going to say, okay, here we go. We deserve to do something a little different. Okay, parent functions. Let's explain what a parent function is. A parent function is something that's going to, for lack of a better term, give birth to other functions. Okay? And it's going to have similar traits, but it's going to be a little bit different. Like you guys have traits like your parents and stuff. Like my, I don't know where the big nose came from, either my mom or dad. I'm not quite sure where, but it did. So anyway, this one we're going to have a constant function, which is be y equals 1. And I'm super bummed the graph paper didn't copy on this. So it's just going to look like this. It's 1 unit up. Okay. From that function comes all the other functions that are horizontal. If I wanted it 5 up, I'd just take it times 5. If I wanted it 4 down, I'd take it times -4. Yada, yada, yada. Okay? The next one is linear. And if it's linear, what's the graph of it? A line. We're going to go y equals x. Y equals x is just that y and x are the same. So I have 0, 0, 1, 1, 2, 2, -1, -1. It just has a slope of 1, and my y-intercept is 0. Okay, those are pretty straightforward, I think. These next two, some of the points are going to be very critical that you get right. Okay? I'm going to let people catch up a little bit. You would think I didn't have 6 cups of coffee this morning. But I did. Next one, quadratic. Quadratic, y equals x squared. Okay, this one's important that you get the points right. 0, 0, of course. 0 squared is 0. Last time I checked. If I plug in 1, what do I get? 1. So we have the point 1, 1. If I plug in 2, what do I get? 4. And the other side, how's it going to compare? The left side, how's it going to compare? Can't be negative, so how's my heights going to compare to the right side? They're the same. And this curves and then goes up. It does not come to a point. It's got a curve. Very important that you get these points correct. This point right here is called your vertex. And then from there, 1 squared is 1, so we go up 1. 2 squared is 4, so we go up 4. Okay? They're not just random points. Those points matter. The last one is the absolute value function, which we talked about that the other day, just yesterday, trying to get you ready for this. Y equals absolute value of x. Remember we talked about absolute value of x. It takes negative values and makes them positive. At positive values, it leaves them alone. So we'll go 0, 0. 1, 1. 2, 2. What's the slope of that line right there? Or of that ray, sorry.
1.
1. So it's actually y equals 1x. That's that part of the graph. Okay? The other side, since the absolute value turns things positive, negative 1 is positive 1. Absolute value negative 2 is positive 2. How would you describe that shape? It's a V. Just a V. This one right now, your parent function is a V at a 90-degree angle. This one has a slope of positive 1. What's the slope of this one over here? Negative 1. You know what? That's a piecewise function. Why? Because it does something for a while, and then it does something else for a while. You need to get it, when you graph an absolute value function, it needs to be a V. So then to answer, yes. Yes. Yep. Okay. The functions, they actually don't affect the x-axis. They just impact my y results are different because the process we're doing is different. Like this one, I'm just making it positive, where this one, I'm squaring it. So then my rate of change is a little different. Okay? So here's what's going to happen, is we're going to modify these two equations, and we're going to talk about how that graph differs. So the first one we're going to do is y equals x squared minus 3. I'm going to come way down here. I'm going to zoom out so you can see both. So the reason why we call this a parent function is because the graph of x squared minus 3 should look like its parent, but it's just a little bit different. What do we have to do to this parent function to get it so it's right when we're looking at the equation x squared minus 3? In other words, what's the minus 3 do?
Just put it down.
Exactly. That minus 3 is just going to move it down. Why? Because my y values are my squareds. None of that changed. I still get 1 as a result. I still get 4 as a result. But that what this does is after I do my function, it moves everything down 3. So this one, he's exactly right. Down 3. So 1, 2, 3. So there's my vertex. That has taken my vertex and slid it down 3. From there, the points move exactly as they did in your parent function. So what do I mean by that? I mean that from there, over 1, I go up 1 to get another point on both sides. From the vertex, 2 squared is 4. So I go up 4 units from there. So how does that graph compare? It's just been moved down 3 units. Good job, Preston. What if it was plus 5? Move up 5. What if it was plus 20? Up 20. What if it was minus 50? It'd be down 50. Okay? Let's flip this over. Make some rules. So if I have any function and I add k units to my results. So this is important. You understand that my function does whatever that function does. I get my heights, and then I'm adding k units. So this is going to go up. I'm sorry. This is going to be a vertical slide. And in this case, it's going to go up if k is positive. What else can I add? Finish this rule for me. It's going to go down if k is negative. So positive would be like plus 1, plus 2, plus 3, plus 4. Negative would be like minus 2, minus 3, minus 10. Okay? So all we do is we take that parent function and go, okay, I got to move that up 5. Okay, I got to move it down short. Okay? Let's go to the other side. Does that look like the last scenario? I would say no. I see some head shakes, and I would agree, no. Because where's the 3 at? It's inside the parentheses, right? Okay, so that's a different ball game. And this one's more confusing. Okay? I'm going to approach this from a conceptual standpoint, so try and get you to understand it. And if you're still stuck, we'll make a rule. Okay? But I want you to try and understand it. Okay? So I'm going to go over to here, and don't write any of this down. Just watch, learn, try and figure out the concept. So I have x and then x squared. Originally, I plugged in 0 and got out 0. Plugged in 1, got out 1. Plugged in 2, got out 4. Okay? So now what I'm looking at is y equals x minus 3 squared. This is funky, but this is all right. What would I... So here's my new x. What would I have to plug in now to still get a result of 0? Can you explain that, Riley? Okay. He's wise enough to see that now to get that same result, I've got to plug in a value of x that's now different to get the same result. Okay? Somebody besides Riley. What do I have to plug in now to get 1? 2. I could plug in 2. But let's try and stay on the positive side. Because you're exactly right. You're exactly right. But I'm looking for a different answer. I need to plug in 4. Because look at this. 4 minus 3 takes me back to my old x that I plugged in, and now I get 1. If I wanted to get 4 as an answer, what do I need to plug in now to get 4? Well, 6 minus 3, it gives me 3, and I square it, I get 9. 5? Well, let's think about 5. 5 minus 3 is 2, square that, I get 4. So 5. Okay? So let's think about this. Here's my old x's. Here's my new x's. To get the same results, my x's that I plug in now have to be what? In comparison. Bigger. How much bigger? 3 bigger. Why do they have to be 3 bigger? Because this steals from my x that I'm going to plug in. So to overcome that, I've got to plug in x's that are 3 bigger than I did before. So I'm going to have this point 3, 0, 4, 1, 5, 4. Let's flip it over. Oh. Okay. So I'm going to plot the point 3, 0. Yeah, I'll tidy this all up here in just a second. Gosh dang it. 4, 1, 5, 4, and we would have the same on the other side. Okay, so if you would describe its slide, how would you describe the slide? From its original spot, what did I have to slide it to get it here? Which direction, though? Right. It went right 3. Okay. Let's try another one. We're going to stick with a square, with a quadratic, because it seems like, that's kind of a good way to go. What if I did this one? Y equals x plus 1 quantity squared. Based upon the patterns you're seeing, from my original location, which is up here at 0, 0, where do you think I'm going to have to slide it to get this graph? Left. That's right. Well, let me explain why. Well, we're going to do conceptual, then we'll explain how this works. Okay. Let me ask you a question here real quick. In my original equation, I'm going to zoom in here a little bit. In my original equation, I want you to think about this. Don't say it right away. Think about what would I have to plug in to get an answer of 9? What would I have to plug in to get an answer of 9? Yeah, so what's the answer? Anybody, what do I have? Right here, what do I have to plug in to get an answer of 9? 3. Okay? Now down here, what would I have to plug in to get an answer of 9? 2. I could get away with plugging in something smaller. Where are the smaller things? They are found to the left. Okay? Flip it over. Let's make another rule. Y equals f of x plus h. I'm going to do this differently than the book. Why? Because I know where you're going in the next few years, and this is going to be the best way to do it, in my opinion. So first of all, where is that h? It's inside the parentheses. It's inside the function. It's the input of my function. It's going to cause a horizontal slide. And I got a rule that I invented here coming up. It's going to go right if h is less than 0. It's going to go left if h is greater than 0. Do a quick example. If I had y equals the absolute value of x minus 5, which way is that going to slide it? Left? Right? Okay, one of you is right. Right. It's the opposite of what you would think. This minus 5? No, we got to move it to the positive 5. Why? Because I can get by with plugging in values of x that are, I need to overcome that minus 5 by plugging in something larger. So this would be a right 5. Here's my rule. I invented this. I patented it. Personally, I love breakfast. I love going out for breakfast. It's my favorite thing on the face of this planet. I stands for inside or input. If I impact my input into a function, which is usually inside my parentheses, what kind of change is it going to cause? A horizontal and if it's minus 5, it's going to be plus 5. So it is the what that starts with OP. One word, opposite. So if it's inside, it's minus 2, right 2. If it's inside, plus 6, left 6. Okay? One last example. What if I did something major, funky McFunkchez? On the outside, what would this minus 6 do? That'd go down 6. The inside, what would that minus 3 do? Left 3. Here we go. Thursday, I need to write this down on my recording. I'm going to start putting these on the boards there so I don't lose them and you guys can see them and come and grab them if you're gone. Of course, if you're gone, watch this stinking video. Page 63, 1 through 12, 37 through 40. There are 4 graphs, 3 graphs, something like that. Piecewise times 3. There's functions on the back that you've got to do for piecewise. We're going to review those every day. And then the worksheet. If you don't want homework over the weekend and you have some extra time, that worksheet's going to be the homework over the weekend. You don't have to do that for tomorrow. You don't have to, but that's going to be the stuff we're going to do over the weekend. I'm going to write those 3 up here so that my people that are gone can get them. But yeah, they're on the back. If you want to take out your phone, turn them on, and take a picture, you can. But I am going to write them up here since I'm recording. We did A and B the other day. Boy, you guys' phones turn on fast. That's amazing. Boy, it's like insta on. The phone can be a useful tool, but in the educational environment, it is incredibly distracting on the most part. So on E, you're supposed to write a function. Okay. You do have some homework time, so please don't just zip up and be done for the day. We still have a good 6 minutes. Nice job today.